Hello everybody, my name is Markiplier and today we're looking at another Try Not to Laugh challenge. No, I'm just kidding. It's Mr. C and we're looking at break-even lessons. Big picture stuff. This lesson is focused on teaching you guys how to calculate a basic break-even point in terms of the number of units that need to be sold in order to break even. Now, in order to do this, you need to be able to differentiate, which means tell the difference between fixed costs and variable costs. So, as you guys know, companies spend money making their products, and this money is called costs. Now, variable costs are costs that change depending on how much stuff you make. And usually these are product ingredients. So, for example, if you're making muffins, the more muffins you make, the more flour you will have to buy. So, flour is a variable cost. Fixed costs, on the other hand, remain the same no matter how much is produced. So, for example, if you have to rent out a restaurant, then your rent is going to be charged no matter how much stuff you make. So, since rent doesn't change regardless of how much product you're making, it's a fixed cost. So, basic term sales revenue, you guys know this, but just to review, when companies sell stuff in exchange for money, that money is called sales revenue. So going back to our muffin example, if we sell each muffin for $3 a piece and we sell 10 muffins, then our sales revenue would be $30. $3 a muffin, 10 muffins, 3 times 10, 30. So sales revenue just means money coming into the business as a result of specifically selling products. Now, the reason I say specifically is because businesses can make money through methods other than just selling stuff. But for now, we're just looking at selling stuff. So that's why we make sure you know what sales revenue is. Okay, lots of text, but bear with me. So, a break-even point is a point at which sales are exactly the same as costs. So, companies spend money to make stuff, right? Let's go back to the muffin example. Companies spend money to buy flour and butter and pay their rent and all this stuff. And they sell muffins in order to gain sales revenue. Usually at the start of every month or at the start when a business begins, and you guys might remember this from the product lifecycle stuff that we looked at, businesses have to spend a lot of money to make products. And the hope is that the money they make, or the sales revenue, as a result of selling those products, overcomes their costs. And eventually they will hopefully break even, meaning that they've paid back all their costs. So break even just means that you've just recovered your cost. You haven't made any profit yet, which is money in addition to paying your costs. You've just been able to pay your costs back. So a metaphor might be that you're jumping into a pool and you're underwater. And you're underwater because you have so many costs to pay. And when you start making sales revenue, you're able to swim towards the surface. And the break-even point is when you've earned just enough money to crack the surface of the water. And you just break the surface and you don't even get your breath yet. You've just broken the surface. After that, when you start making profit, that's when you can draw a breath in. So, a little dark for a metaphor, but I think visually it works. But anyway. So, if you recall from our PLC lesson, when a product is first introduced, businesses are losing money because they've had to spend a lot to create the product and market it. When they start selling, they start recovering those costs. When those costs are completely recovered, but they haven't made any profit yet, they've reached the break-even point. So, total cost is equal to fixed cost plus variable cost. And sales revenue is equal to selling price times the number of units sold. Now, we went through that already, but I thought I'd just write it down. Profit, which is money left over, is sales revenue minus total cost. So profit is what you get after you've paid your total cost. Now, once you've broken even, profit equals 0. Because if our sales revenue exactly equals our total cost, then we've got, say, 10,000 minus 10,000. So our profit is going to be 0 at the break-even point. Now, before the break-even point, our profit's going to be negative because we haven't paid all our costs yet. And after the break-even point, our profit can be positive because we paid our costs back. Now we can actually put some money in our pockets. So we're now going to look at variable costs specifically, and we're going to go through an example with them. Now, for our example, we're going to use a bakery. Now, I know earlier I was talking about muffins, but we're going to change it up, talk about bread. Mainly because the picture of the bakery has a loaf of bread on it. So, now going through, each product has different ingredients and requires different things to be produced. So if we look at bread, bread needs yeast and flour and butter and eggs and sugar and salt and water, usually. Now, the more bread we bake, the more ingredients we're going to use. So our variable costs would be these ingredients, and our total variable cost would depend on how many loaves of bread we bake. Now, if we list our variable costs, they would be the cost of flour, eggs, yeast, butter, sugar, salt, water per loaf. Usually variable costs are done on a per unit basis, and the reason will become clear when we actually look at the break-even formula. Now, don't freak out. It's a very easy formula. It's just a fraction. But we look at we look at variable costs on a per unit basis. So in this case, it would be per loaf of bread, or per box of Cheerios, or per drill. You know, if you're manufacturing drills. I don't know why I thought of drills, but anyway. So, moving on. Take our bakery as an example. We know that variable costs change depending on how much we make. So far we've listed our variable cost as flour, eggs, yeast, butter, sugar, salt, and water. Now each of these costs will have a dollar amount attached to them on a per loaf basis, meaning, the amount for each loaf. Now this cost is usually estimated by business owners because you can't buy just enough flour to make one loaf usually. Businesses will buy big sacks of flour because they buy products in bulk. And then, they just use whatever flour is needed. So in order to do these kinds of calculations, business owners will estimate what their variable costs are. And over time, their estimates will get better. But anyway, the point is that you guys don't need to stress about getting 100% accurate estimates for this stuff. For the task that's coming up, if you want to, go into level 4 territory, then you should do a little bit of research, to see how much, say, a bag of flour is. And then if you look at a recipe, you might see, so a loaf of bread takes around 3 cups of flour. So, and we know that a loaf of bread, a bag of flour has, I'm not even sure how much it has. I'd have to do research. But let's say it has 20 cups of flour in it, and you're using 3. And so if you know that a bag of flour costs, say, $5, and you're using 3/20ths, then you can do the math on that. So I just came up with these costs. I just made them up. So assume that your estimates are as follows. Flour is 50 cents per loaf. Yeast is 30 cents per loaf. Sugar is 5 cents a loaf. Salt is 5 cents a loaf. Water is 10 cents a loaf. Eggs, 50 cents a loaf. And butter, 30 cents a loaf. Again, I just made this up. If we add all this up, then our total variable cost per unit, or per loaf of bread, is $1.80. So, this plus this plus this plus this plus this plus this plus this equals $1.80. So that's what our variable cost is per unit. Usually we say per unit, and the word unit applies to whatever product we're talking about. So if we're talking about loaves, then a unit is 1 loaf. If we're talking about drills, most random example ever, we're talking about drills, then a unit would be 1 drill. Okay. So we know that our variable costs are $1.80 per loaf of bread. Now, if we were to bake, say, 100 loaves of bread a day, then our total variable cost would be 100 loaves times $1.80 per loaf, to equal 180 loaves a day. So if a bakery were to make 100 loaves a day, then it would cost them $180 to do that. Now, let's say this bakery makes really good bread. People just love the bread at this bakery. And so, after a couple good reviews on Yelp, their demand skyrockets, and they end up having to make 3,000 loaves of bread per day. That is a lot of bread. Now, if we do the math on that, we take 3,000 units times $1.80, we get $5,400 per day. So you can see, the only reason I show you this is to show you how quickly variable costs can go up the more stuff you make. And so, you know, a lot of people think that businesses can just make more and more and more and more, and that's not the case. They have to be able to pay for it. And more importantly, their sales revenue has to be greater than this so that they can pay it off and still have money left over to pay for other things. But anyway, the main message here is the more products we make, the higher our variable costs are, and that's why they're called variable costs, because they vary. For anybody who doesn't know, the word vary means to change, specifically to change in relation to something else. In this case, it changes according to how many units we produce. Okay, we're going to change gears now to fixed costs. So going back to our bakery, fixed costs are costs that don't change. So looking at this cute little bakery, what costs do you think they'd have to pay that don't change regardless of how many loaves of bread they make? So rent is one, store cleaning is another, baker salaries. So if you hire a baker, you have to pay them, you know, they have to be able to live, right? So you've got to pay them a salary regardless of how much work they do. You know, if they come in and no one buys bread, you know, they still came in, so you still got to pay them. Things like utility bills. So things like internet, hydro, your electric utility bill would be untouched. You'd still have to keep the lights on 12 hours a day, let's say, right? You wouldn't turn the lights off if you're not baking as much bread, because your employees still need to see, right? If you're using a wood burning oven, then your utility bill would be a fixed cost because your hydro probably isn't going to change that much. If, however, you're using an electric oven, then your hydro, which is electricity, might change a lot depending on how much stuff you bake. So all to say, you just need to keep in mind what you have to use in order to produce whatever products you're making. And so this needs to be given some active thought. So going back to the oven example, big tools like an industrial baking oven are very expensive. They're usually mortgaged out. They're not something that people usually buy in cash. I mean, it can happen sometimes, but you know, industrial ovens can cost like $50,000. You know, they're expensive, and they're big, heavy pieces of equipment. And so sometimes they're mortgaged out like a home, just with a lot less money, you know, like 50 grand mortgaged out instead of 400,000. So usually we treat big expensive machinery like this the same way rent is treated, in the sense that we regard it as a fixed cost that's paid on a monthly basis, because we pay rent on a monthly basis. Now, fixed costs, again, don't change based on how many products we make. And they're usually looked at on a monthly basis because you pay rent monthly, you pay big expenses like an industrial oven monthly, you pay salaries monthly, you pay your utility bills monthly. So, good rule of thumb is anything that's paid monthly is going to be a fixed expense. So let's look at some figures. With this bakery, we can assume that rent is likely around $3,000 a month. I wouldn't expect you to know that. I'm just, based on current real estate prices, you probably have to pay that much if you wanted to actually rent out a bakery. Now, we could guess, let's say, that the oven costs around $700 a month. Now, this is repaying a loan. When you get a big loan for something, like let's say you take out a loan for 50 grand to buy an industrial oven, you have to pay that loan back. And so we could just assume that the loan payments for each month is $700. We're just making this up. Now let's say that you pay your bakers $2,700 a month. And let's assume you have 2 bakers. Which means if you're paying each of them $2,700, then the total amount of salary that you have to pay, excluding your own salary, because the owners don't usually pay themselves a salary, you're paying $5,400 a month. Let's say utilities are $300 a month. So this is heat, internet, and hydro. Let's say that that's $300. And store maintenance, so just taking care of odds and ends and stuff, cleaning the sign, cleaning the windows and things like that. Let's say that costs $100 a month. If we add all that up, then we get a total fixed cost of $3,000 plus $700 plus $4,500 plus $300 plus $100 to give us a grand total of $9,500 per month in fixed cost. When we run a business, we need to be able to make back the money we spend running it. Otherwise, the business dies. So, we need to completely recover the money we spent paying our fixed and variable costs. When we've done exactly that, we break even. When a business breaks even, it means they've just sold enough units to recover their cost. I know I'm repeating myself. I'm just hammering this point home. The number of units sold required to recover costs and to break even is called the break-even quantity. So every business, no matter what they sell, has a certain number of products they need to sell every month in order to break even. And it will change very much depending on what the price of the product is and how much it costs to make. So before I actually give you the formula, I just wanted to show you this fun slide where I want to show you graphically what the break-even point looks like. So this line here represents the costs that we have to pay. And the more stuff, the number of units, the more stuff we make, the more we have to pay. So the x-axis, sorry about the rectangle, the x-axis is the number of unit sales. The farther we go in this direction, the more units we're producing and selling. The y-axis represents dollars, either costs or sales, doesn't matter. And the higher we go, the more money is involved. So this top line here represents our costs, and the more units we make, the more we have to pay. Now the reason we're starting up here is because we have a guaranteed fixed cost per monthly no matter what. Or I meant to say monthly fixed cost and fixed cost per month, and my brain just fused them together, so sorry about that. So yeah, mathematically speaking, the reason why we don't start at 0, which is this point right here, is because before we produce anything, we've got to pay our fixed costs. Because our rent is still due, we still have to pay for that gigantic oven, we still have to pay our employees' salaries, we have to pay for all our fixed costs before we sell one thing. So immediately, right off the bat, before we sold anything, we've got all this fixed cost to deal with. And then the more stuff we sell, the higher our costs get. Now, it's not all doom and gloom, because every unit we sell, we make money on, right? And that's called sales revenue. Now, our price is going to be higher than our cost. That's the only way we can make any money. And so what that means is that we're going to make money faster than we spend it. And the goal is to sell enough to make profit. So what happens is, as we make stuff, our costs go up, and they keep going up. But also, as we sell stuff, our sales revenue goes up. And eventually, there will come a point where these two lines intersect. And what that means is that our sales revenue, represented by this line, and our total costs, represented by this line, intersect with each other. Now, you might be saying, hey, Mr. C, why are we starting at 0 for sales? And that's because we don't make any money without selling stuff. So until we sell stuff, the amount of money we make is 0. And then when we sell one thing, bam, 2, bam, 3, bam, 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 bam. And so we climb up a perfect linear line that starts from 0. Our costs start up here because we have to pay a fixed cost no matter what. For sales, we don't get any money until we actually start selling stuff. Now, the break-even point is where these two lines intersect each other. And so right when sales equals the same amount as costs, and that's our break-even point. Now, you guys know this already. I'm just showing this visually for all you visual learners out there. You can see what's happening. Now, after that intersection point, our sales keep going, hopefully. And after this point, our sales are higher than our costs now. See, this is our cost line. And so our cost line keeps going because it costs money to make stuff. But after the break-even point, we're making more money than we're spending. And so this zone here where sales is higher than cost is profit. And this is represented by Aziz Ansari throwing singles in the air. And down here, oh, the rectangle. Anyway, she's saying, that's Detective Santiago from Brooklyn Nine-Nine, and she's saying crushing debt. So yeah, down here, crushing debt. Up here, making it rain. So visually, this is what breaking even looks like, is where your total costs intersect exactly with your sales. And anything after that is pure profit. All right, so now to the crux of our presentation, the break-even formula. There is a simple formula that will actually tell you exactly how many units you need to sell, no matter what it is that you make, in order to break even. Now, in order to use this formula, we need monthly fixed costs, variable costs per unit, and whatever price you intend to charge per unit. So this is what the break-even formula looks like. Super simple. It involves four things. Q represents the break-even quantity. Now, just a refresher, the break-even quantity is the number of units you need to sell in order to just repay your costs back. So the number of units you need to sell just to pay your costs back is equal to your total fixed costs divided by the difference between the price you intend to charge people and the variable cost that it costs to make that product. Because whatever money is left over after paying your variable cost goes to paying back your fixed cost. And eventually that leftover money will pay back that fixed cost. And so the division just tells us how many units we need to sell in order for that to happen. So, break-even quantity is equal to total fixed costs divided by price minus variable cost. This is in brackets because we're actually dividing fixed costs by whatever the difference between these two is. Now, an important relationship to know is price is whatever you decide. Your variable costs aren't really up for you to decide. So your product is going to cost whatever it costs. Your price is something that you control. So the higher the price, the bigger the difference between these two numbers is. And hopefully you guys remember from your math classes that the bigger the denominator in a fraction, the smaller the fraction is. Right? So if you have, let's say this is 10 and P minus V is equal to 1, let's say. So 10 divided by 1 is just 10, which means that you're going to have to sell 10 units. Your Q is going to be equal to 10. 10 divided by 1 is equal to 10. Now, let's say you double your price. So then P minus V is going to be equal to 2 instead of 1. And so 10 divided by 2 is equal to 5. So by doubling your price, you're doubling the difference here as well, which means your break-even quantity is going to be halved. So the bigger this number down here, the smaller your break-even quantity is going to be. And so business owners will tinker with their price to get a break-even quantity that they think is acceptable. For example, with going back to our selling bread, if bakers don't think that they can sell 3,000 loaves, then they might increase their price a bit so they don't have to sell quite that much. But anyway, we're going to go to an actual example of carrying all this out. Okay? So going back to our bakery example, we know that our fixed costs are equal to $9,500 a month. We already know that our variable cost per month is $1.80 per loaf. And now, for the purpose of this lesson, we're just going to make up a price. Normally in my business classes, I have a lesson on price and stuff like that, but because of the whole COVID-19 thing, we don't have time. So we're just going to make up prices. So let's just say that our price per unit is $7 a loaf. So yeah, I'm just making this price up. So if we want to know how many loaves of bread we actually need to sell in order to break even, we use our break even formula right here. It's the same formula, I just typed it out instead of having that picture. And then we substitute our values. So hopefully you guys remember this from math. We substitute our values into the equation. So we have fixed cost, $9,500, divided by our price, $7, minus our variable costs, $1.80. So if we do, remember your bed mass, don't forget bed mass, super important. If we do our bed mass, we have Q is equal to 9,500. That part hasn't changed. So it's 9,500 divided by 520, which is the difference between 7 minus $1.80. Now, if we do the math on this, 9,500 divided by 520, we get an answer of 1,826.92 units. So what that means is that this bakery, in this example we've been looking at, will have to sell 1,826.92 loaves of bread in order to just break even. They haven't made any profit yet. They're just breaking even. But mathematically, we can't sell 0.92 of a loaf, right? You can't just go to a customer, chop off a piece. Here you go. So we always round up. Because if you round down, you will not have broken even guaranteed. If you round up, then you've broken even and then a little bit more. So in this case, in reality, the number of units we have to sell to break even is 1,827. And that's our break even point. A normal bakery could probably sell that much. But if a baker thinks that they cannot sell that much, then they either need to lower their fixed costs to a smaller amount, or they need to raise their price to make this fraction smaller. So they might decide to raise their price up to $8 or $9. I mean, $9 for a loaf of bread is pretty darn expensive. So they might try to find ways to make this smaller. Actually, hot topic right now, with all the closures and things like that are happening because of COVID-19, companies are making far less money than they used to, but their fixed costs haven't changed. And so if you've been wondering why so many companies have been laying people off, it's because they can't afford to pay their fixed costs anymore. Because their sales numbers, they're not able to sell that much. You know, because people aren't going out, they aren't buying stuff. So they might only be able to sell 1,000, which means they're not breaking even. So they need to take steps to lower this amount. And so that's why they're firing people or letting people go or closing down locations so they don't have to pay rent. They're doing that to lower the fixed cost stuff. So anyway, if you've been wondering why that's been happening, that's why it's been happening, is because they can't break even any longer. So, we're almost done. Continuing. Q equals 1,826.92, but we're rounding up to 1,827. This means that in order to recover our costs and break even for the month, we need to sell 1,827 loaves of bread. Any loaf of bread that we sell after that, or in addition to this, will bring us into the green profit zone, meaning the money goes directly into the owner's pocket. You might have noticed that price, as I've said, has a huge impact on this. So does fixed costs. Those are the two big ones. Yeah, if we raise our price, then our break-even quantity will become much smaller because we're making more money per unit. It also means that we might sell fewer units. Remember from demand? What happens if price goes up? What happens to demand? You guys should remember this. If price goes up, demand decreases. Hopefully that was your guess. Because people can only spend so much money, right? So if things get more expensive, then people can't buy as much. So as a business owner, you'll have to make these decisions. You'll have to decide, okay, I want to sell fewer units, which is fine, but if I raise my price, I actually will sell fewer units because people can't afford it as easily. So it's a balance you have to make. Conversely, if you lower the price, you'll have to sell more, but you probably will sell more because people can afford it. So yeah, I hope you enjoyed this video. I hope it wasn't too repetitive. I wanted to make sure that I hammered the important notes home. But math is important, and doing stuff like this is what helps people figure out if they can actually run a business or not. So, and I will see you in the next video. All right, bye.